like I said, one really bizarre consequence of Green's theorem is that if you use this vector field, that vector field has a curl of 1, and so this is what Green's theorem would say, is if you took a path integral around, let's say, the boundary of some region of that vector field, then that's equal to the area of the region. Right? It would be the double integral of 1 over the region, which is also known as the area. So if we wanted to find the formula for the area of an ellipse, and this is the equation for an ellipse, what we could do is we could say, let's take the path integral around the boundary of the ellipse of this, this vector field, and that's going to be equal to the area. So first of all, we have to parameterize what that curve is going to look like. And that curve is going to be a curve A cosine t, comma B sine t. A circle would just be cosine t sine t, but since this is an ellipse, we're giving those extra A and B parameters so you can vary the major axis and minor axis of your ellipse and stretch it however you want to. Okay, so this is just the path around an ellipse, where t would have lower bound 0 and upper bound 2 pi. Because between 0 and 2 pi, my sine and cosine functions are going to go through a full period, and then we'll end up where we started. Okay. Okay, so this integral then is going to be the integral from 0 to 2 pi. And then on the inside, since this is a path integral over a vector field, we have to take the dot product of that vector field, which is negative y over 2 x over 2, with not the path, but actually the, what do we call it, the derivative with respect to t of my path. And so that's going to be negative a sine t, comma b cosine t. So dt. Of course, whenever you plug in x and y, this is going to be x and this is going to be y. You just take that from your actual path. So this is going to be the integral from 0 to 2 pi of the dot product negative b sine t over a, no, not over, but second entry here, a cosine t. I'll take the 1/2 scalar outside the integral, and then dotted with negative a sine t b cosine t. So take the dot product of those vectors, that's your integrand, integrate with respect to t, plug in your bounds, don't forget the 1/2, and this should give you something like pi times a times b when you're all done. And so that's the formula for the area of an ellipse if you know the length of the major radius and the minor radius.